Okay, now for question number 2. We have here that a block of mass m equals 8.4 kilograms moving on a horizontal frictionless surface with a speed of 4.20 meters squared, and it makes a perfect elastic collision with blocks m at rest. After the collision, the 8.4 block recoils with a speed of 0.400 meters per second. In the figure below, the blocks are in contact for 0.200 seconds. The magnitude of the average force on the 8.40 kilogram block while the two blocks are in contact is closest to. So it's asking us for the magnitude of the average force while the two blocks are in contact, right? So something important to know basically is that to find the force, we use this formula. We're going to use this formula here. The force acting upon the change of time is equal to the change in momentum. And we should have enough. It gives us all the information. We have the change in time and we have the change in momentum to figure, and then we just solve for the force. And that's what we did. It's important to know though that for the change in momentum, it's the same thing as saying the mass times the velocity of the final minus the velocity of initial, the change in velocity basically, right? So we have this, the force times 0.2, and then we fill in this, the mass, which is 8.4, and the velocity final, which is negative 0.4, minus the velocity initial, which is 4 here, and I believe this actually has to be squared. And one moment, let me just recheck that. This is actually 4.2, my bad. 4.2, correct. Yes, this is 4.2. This is actually supposed to be 4.2. That's the velocity initial, and then you solve for everything. Once you have that, you can just solve for f, and you should get 193 newtons right here, and that's your answer. So the answer would be B.